Here we look at the 1,2 addition of HCN. Now, we call it an addition of HCN, although if we were doing this reaction in the lab, we'd pretty much never use HCN itself, because hydrogen cyanide, of course, can be quite deadly. And so this typically, for safety reasons, instead uses potassium cyanide. Now, in this reaction, it's similar to pretty much any other 1,2 addition. We take the nucleophile, CN-, and add it to the carbonyl. It does direct attack, push electrons up onto oxygen. Notice that we would never do this reaction under acidic conditions. Acidic conditions can convert potassium cyanide into the much more deadly hydrogen cyanide. And along those same lines, we don't necessarily quench this reaction with acid, but just with water, which allows us to protonate to form the alcohol. And this can be done with any variety of different aldehydes and ketones. Forming the cyanohydrins. Now, nitriles themselves aren't always the most useful functional group, but what they are highly useful for is the fact that nitriles can easily be converted into carboxylic acids or amines or a number of other different useful functional groups. Now, one very, very interesting application of this reaction is the following. So there is a millipede, Apheloria corrugata, which actually stores the cyanohydrin in it. And just like so many other 1,2 additions, this CN- addition is completely reversible. And so this millipede, when it's attacked, will actually undergo a retro HCN addition. So it will go backwards, and it will convert the cyanohydrin back into the aldehyde plus hydrogen cyanide, and that's how it's able to fend off predators. And again, that's why we don't use HCN for this reaction, because HCN, very deadly substance.